Morning, everyone. Can you hear me? My name is Matthew Kleps. I'm from Cleveland State University, as he said, and I want to compare virgin glass fibers and recycled glass fibers in local pavement. Now, this problem arises from, in Ohio and in Toronto, we have a lot of freeze-thaw cycles from the winter, and the water goes into the pores, and then it thaws in, then it freezes, and then there's a tensile failure. And then to deal with all the ice that we have on the road, we put a lot of salt on it, and this is going to damage the pavement. So what we want to do was find a way to mimic asphalt behavior by implementing glass fiber reinforced concrete. But then there's still questions on how do you optimize it? How do you optimize the workability, the mechanicals? How do you do all that? So we look into that, and then also we're going to look into the cost assessment and how it affects the environment. Now, one of the first things we do is we made a control mixture, and then what happened is we increased the amount of aggregate. If you look at this, the picture's up there, we can see the difference. There's more aggregate, there's going to be more supplementary cementitious materials, and then the amount of cement paste is going to be lowered, and then to make up for strength and increase the tensile strength, we're going to increase the fibers. Now, this is the program we use, checking for workability, compressive strength splitting. Everything's standard here, except it might be noted that we are looking at flexural performance instead of flexural strength. That's because we're going to look at more factors than just modulus of rupture, some residual strength, and then toughness. So for the mixture proportioning, how we got to our control to begin with is we have a tarantula curve. Now, what you're trying to do is you're trying to stay within the dotted lines as much as possible, right in the middle, and that gives you the best workability for your mix. And this is to mimic how ODOT makes their mixtures, because this was an ODOT project. And then additionally, you can see the proportions we use. You can see the low amount of cement, and then you can see the high amounts of aggregate, and then also the high amounts of SCMs. And then along with this mix, we had 12-pound replacements of fibers, and these were the fibers that we used. We used virgin glass fibers, which were about 1.5 inches, so more macro. The recycled fibers, which were about 1 millimeter each. And then you're probably looking at this, and then you're going to say that's not 1 millimeter. When you zoom in, they turn into 1 millimeter in length. This is them clumped up right now because this is wool insulation. And then also looked at polyfin fibers, which were about 2 inches. And then when we look at the scanning electron microscope, these are all going to be in the same scale. If we just looking at it, we can see the difference between micro and macro with the recycled glass fibers. So when we zoom in, we're going to see how straight and nice and organized, if you will, the virgin glass fibers are versus how random the matrix is with the recycled glass fibers. And then the virgin polyfin, something that is interesting with it is it has a deformed pattern like rebar, so it can better grip onto the concrete matrix. And that's later on going to allow pull-out behavior instead of failure by rupture. And it's going to be one continuous fiber, comparatively to the other ones, which are a mixture of them. So we zoom in more. You can really see the difference. Although the diameters are about the same, it's the organization of it. Now, looking at workability, workability is heavily influenced by the geometry and the aspect ratios, because just because the aspect ratios were doubled, it doesn't explain the massive drop in slump that we see from the reinforced or the recycled fibers. So that's because of the geometry and how they want to interlock, and they don't want to flow. So another thing is with the amount of slag used, when you have lower cementous, just cement mixes, there's lower water demand. And then fly ash allows for a ball bearing effect where there's less friction between the particles, so it can flow better. And then superplasticizer will have to be added to make up for the recycled fibers. But currently, we're just trying to compare the virgin fibers to recycled fibers to see what we can base off of. Looking at compressive strength, these are all going to be relative to 28 days. We can see virgin had the best effects for compressive strength, polyfin, nominal, and then the recycle had decreased the compressive strength. Then when we look at the splitting tensile, we're going to see that the virgin also did best, then recycled. Polyfin did best, then virgin, then recycled, decreased again. But the story starts changing when we get to what we care about the most, which is flexural strength or the modulus of rupture. We're going to see that it's going to exhibit the second highest of this, the second highest modulus of rupture. And it's doing better than the polyfin fibers. So next we're going to look at fractured specimens. And then you can start reading into the failures when you look at the fractured specimens. So here, what's happening is there's actual failure. Like the fibers are failing, rupturing in the virgin fibers, and then a similar effect is happening with the recycled. But with the polyfin, you're going to see a pull-out behavior. And because of the deformed shape, it's going to have more friction, and it's going to lead to a second peak. It's not going to be a high peak, but it's going to be there. So we look at the flexural performance. We're going to look mostly at more than just modulus of rupture, like I said. That's going to be the first peak. We're going to look at the residual strength at L over 600 and L over 150, which is going to be 0.02 and 0.08 on the deflection graph. And then also we're going to look at toughness, which is going to be the energy that can be absorbed, and that's the area under the graph. And when we compare those, we can see polyfin did best, but the recycled fibers did second best. And then the virgin fibers came in and they got third, better than control when it comes to this, but not the best. And then, so that's really proving that this is good for pavement applications. We need to absorb the energy. And then another big thing with this is chlorine penetrability. So with RCPT testing, we can see that all the mixes were very low or less. The virgin fibers were actually negligible. And then the recycled fibers had increased the penetration, but it's still in the very low range, because when we look at the whole ASTM as a whole, we can see how nominal it is. And you still have to consider it, but it's still doing pretty good. And then another thing we look into is drying shrinkage. We moist cure it for 7 days, take the measurements, and then air dry it. Leave it out in just the laboratory, normal temperature, and then we see that virgin fibers do best again. Second, recycled fibers. But the polyfin fibers increase shrinkage. So another thing that we have to consider is the environmental impact. And then we're going to see that our control mixture compared to two ODOT mixtures are going to have less carbon produced per cubic yard. And then additionally, because we plan to use the recycled fibers, for each local roadway, each mile you go of 2 lanes, you're going to use about 56,000 pounds of this recycled fiber. And then when looking at the cost of it, because everyone's going to ask what's the cost, and it's a very good question. If you haven't seen this kind of graph before, I'll give you a quick introduction. It's just a contour map if you think about it. And then I have the metric tonnage price on it, and you can see how much it costs. So this is going to be the first ODOT mixture. This is $71. The second one, that's $84. And then control, which is only our control, which is $58. And the big thing is we reduce the cost by not using as much cement and using cheaper aggregates to fill in the gaps. So overall, the virgin fibers had the best compressive strength, flexural, chloride penetrability. The polyfins had the best flexural, But the biggest thing is, notice how I kept on saying over and over, recycled fiber was second to. For it being a free solution to incorporate and it giving a second life to a product, it's very feasible to start incorporating that into the mixtures. So, and then especially because it showed potential, even compared to virgin fibers, to do better in flexural performance and in drying shrinkage. And then overall, just the control mixture that we developed, omitting the fibers added, had a lower cost compared to ODOT mixtures, and then the environmental impact was a third.